Hello and welcome to Tech Deals, overclocking the i3-8350K and system RAM. In this video, I'm going to show you how to overclock, what settings to change. I'm going to show you how much additional power and heat that produces. I'm going to show you some benchmarks and talk to you a little bit about the pros and cons of overclocking. Now this is part 3 in a video series. Linked down in the video description below is the playlist of all the videos. The first one is the parts overview, part selection, the choices, the total budget. $800 is what the system cost to put together. Part 2 is a detailed why look into this CPU. Many people ask the question, why in the world would you buy an i3-8350K? Isn't something like an i5-8400 or a Ryzen 5 1600 a much better buy? You'd think, and for many people it would be. But there are people and there are use cases that make this CPU actually a better choice. Watch the first and second video if you'd like a detailed discussion there. We're not going to rehash that topic here because I already did that. Instead, we're strictly looking at overclocking in this video. Now, what I'm about to show you would in fact apply to the i5-8600K and the i7-8700K to a point. You should have better cooling and maybe one step up on the motherboard. If I was doing an i7-8700K, a Z370 Tai Chi board from ASRock, for example, might be a better choice than the Killer SLI. The Killer SLI is a great board, but if you're spending $350 on a CPU, buy a next grade up a motherboard. It comes with some better features, better power delivery, etc. But for this CPU, and honestly maybe even an i5-8600K, this is a good all-around board. As for system RAM, I deliberately put DDR4 2133 in here. This is Corsair Vengeance LPX, but it is stock 2133, but we're going to overclock that. I'm going to show you that in the BIOS and talk about my experiences there. Full disclosure, it doesn't make a huge difference to performance. Running it faster doesn't change the overall performance by as much as many people think. It's a little bit. It makes the system a little quicker, but it isn't a huge jump. The real jump is in overclocking the CPU. Before we jump into the BIOS and start showing you overclocking, I need to give you a big overclocking disclaimer. Number one, you can actually destroy your hardware doing this if you don't know what you're doing and you change things that you don't understand what you're changing. I'm not talking about the system not posting or not booting or blue screening. I'm saying you can actually destroy your chip. Feed too much voltage through it and you'll fry it. You can damage motherboard components by turning up the voltage on motherboard components too high. Voltage is what kills this stuff generally, not clock speed and not temps. There is a temp protector on this, unless you turn it off manually, which I hope you wouldn't, that basically will auto-throttle the chip if it gets too hot and will physically shut the machine down if the temps exceed a certain threshold, a certain margin for safety. So modern-day systems will generally not fry due to temperature. 15 years ago they would. Overclocking the original Athlons, for example, you could quite literally cook those chips. But those days are past. These have thermal protection. They don't necessarily have voltage protection. In my opinion, the maximum safe voltage is 1.35 volts. That's on the CPU's V-core. You can go higher. You can give this CPU 1.5 volts if you want. I won't. I did 1.45 volts briefly for testing just to see how high I could get it, but even that made me a bit uncomfortable. 1.4 is the most I normally go for my overclocking testing. I did 1.45 on this, and then I ended up bringing it back down to 1.35. There's a huge temp and power delivery increase as you increase the voltage, and certainly with a 120 millimeter liquid cooler, there's a limit to how much you're going to be able to do voltage-wise. A 240 at 1.4, 1.45 would be more useful, but that's too much money to spend on a 4-core, 4-thread i3. Instead, what I look for is the best clock speed I can get at about 1.35 volts. That's where I have my i7-8700K on my test bench overclocked to. That's what I overclock my AMD Ryzen chips to. I find the maximum clock speed they'll take at 1.35 volts. As a general rule, I don't mess around with most of the other motherboard settings. They tend to behave a bit differently from board to board. If you want to tweak and play with it, by all means, just keep in mind that the more advanced settings you dive into in the BIOS, the more chance there is that you turn something on or off that physically destroys your chip. I personally don't think another 100 megahertz is worth it, but that decision is yours. The other point I want to bring up is every chip is individual and unique. My results will not be your results. Your motherboard will be different. Your physical chip is different. Your cooling may be different. The ambient temperature in your room may be different. And of course, every chip is slightly different in manufacture. One of you might get 4.7. The next guy might get 5.0. Different chips, different boards, different setups, different BIOSes, different updates. There's many different reasons why you may get different results. Don't watch this video and expect to exactly replicate my results and assume it must work just because it worked for me. You might get better, you might get worse. Everybody's results are individual and unique. And with that big disclaimer out of the way, on to the overclocking. This is the first screen you'll see when you press the delete key and go into the BIOS, at least on this motherboard. It's going to look a little bit different on each board. The first thing we want to do is we want to change the Xmp Profile to either Profile 1 or 2, depending upon your system RAM. It's currently set to auto, so we're going to click on that and change it. All this really does on this RAM, since it's DDR4 2133, is ensure that the various settings are what the RAM is expecting, in this case a CL rating of 13. Now to make further changes, we have to press the F6 key, F7 on ASUS and other boards, but F6 to go into the advanced mode, come one over to the overclocker tweaker, and come down to the DRAM configuration. Again, this looks different on every motherboard, so you kind of have to read what's on the screen and figure it out from there, which is why you can't make a universal overclocking guide simply because they look different. Now I'm actually taking the Xmp Profile out here because we're going to be doing manual overclocking. If you're not, then just leave it in. I'm coming down here to DRAM frequency and I'm going to set the RAM speed to 2666. You can see there are a huge number of choices here. Yes, you could theoretically select 3200, but it's not likely to work on RAM that's sold as 2133. So I'm setting it to 2666. Now, the auto mode says 15, and it might work, but I can actually tell you from experience, this doesn't work. I did have to manually set these. So I'm setting it to a CL rating of 15, which is a little bit slower than the default of 13, but it's also running faster. I set the TRAS line to 38, adding 2 to that as well, and making the write recovery time 17. You might ask, why did I pick these numbers? Why 15, 15, 17, 38? It's kind of out of order there. And the simple answer is that's what worked. I played around with a number of settings here. Leaving it on auto did not work. It was not stable. And just setting it to 15, 15, 36, 16 didn't work either. So you're going to have to play around with it and find the settings that work for you. And it may require multiple reboots and some stress testing to find a setting that in fact does work. This is what worked for me on this particular RAM. At this point, you just press F10 to save your settings. Most boards are F10 these days to save the settings, and reboot, and it should save them. That was system RAM overclocking. You can do it. And if it's stable, awesome. You get a free performance boost. Although, as I said earlier, it is not a large performance jump. The truth of the matter is, and I played around with various benchmarks, it's very, very hard to tell the difference between 2133 and 2666 unless you're really looking for it. On a day-to-day use of the system, it's pretty small. That being said, the only reason I think that applies is if you either find a really good deal on 2133 or you already had it sitting on the shelf, as I did. I had this sitting over there for quite some time. If you are buying new RAM today, the price difference between 2133 and even DDR4 3000 is very small. Do yourself a favor, just buy DDR4 3000 and save yourself a world of trouble. Set XMP in the BIOS and don't worry about it. And with that being said, let's move on to the CPU overclocking. Here we are in the system BIOS. When you press the delete or F2 key, this is the first thing you see. There are several ways to overclock most motherboards. You can see here we're running at the default of 4 gigahertz. There is an easy overclock option, and most modern boards that support overclocking have such a feature. It does set the fan speeds to full speed, and when we go to advanced mode, you're going to see what it changes over here. Going to CPU configuration, it sets the CPU to 4.4 gigahertz instead of 4 gigahertz. It sets the CPU cache ratio to 37, and it changes the voltage, which we'll go look at in a minute. The Avx ratio, it sets to 4, which is actually a negative number. It makes some other changes down here as well. Whether they make a difference or not, I'm not entirely convinced they do. Coming down to voltage, it does increase the voltage to 1.32. 1.32 is pretty aggressive. That's a lot of voltage for 4.4 gigahertz. It probably would work at auto or stock voltage at 4.4. That's not a huge overclock. But when you have the automatic overclocking settings that the motherboard companies provide, they tend to be fairly conservative because they want it to work for everybody. But it produces needless noise, temperature, heat, and wear. So we're going to turn that off, and I'm going to show you two other ways to overclock besides just hitting that easy button. First things first, we're going to manually set the voltage to 1.35 volts, leaving the load line calibration set to level 1, which is where I personally leave it on most of my configurations. We're going to come up here to the CPU itself, and we're going to set an all-core number here of however much we want our clock speed to be times 100. So 45 would be 4.5 gigahertz. 46 would be 4.6 gigahertz, 47 would be 4.7 gigahertz. You can see the changes in real time up there. It's not actually making them in real time. This is just telling you what the target is going to be. Now, 48 or a 4.8 gigahertz overclock is really nice. I'm leaving everything else down here at auto. The only other change I'm going to make is to increase the Avx Ratio Offset. Now, I played around with a lot of different settings here. I'm showing you the final best numbers that I got to. Rather than show you 22 different settings, this is what worked for my chip. A negative ratio of 3 for AVX. So when the FPU or AVX instructions are being used, it'll actually be 4.5 instead of 4.8. Everything else down here is left on auto. This worked right here. 1.35 volts, 4.8 gigahertz clock speed, negative AVX3. This was stable. This is where I benchmarked at. This chip would not do 5 gigahertz regardless of settings. Even 1.45 volts didn't make a difference. So we come back here, and you'll notice it says 4 gigahertz because we haven't changed anything yet. F10, save configuration changes, and reboot. And we're going to press delete and come back into the BIOS. Once we're back in the BIOS, I'm going to press F6 to go into advanced mode. It says 4 gigahertz up there because it's set to boot to the non-turbo mode when you first boot the system. It'll jump to the overclock settings once you actually get booted up. But as you can see here in the CPU configuration, it saved it. There's 4.8 gigahertz there. But instead, we're going to choose this. This is another way to auto overclock without using the turbo button, and this gives you a choice of 4.4, 4.6, or 4.8 gigahertz. Notice it makes similar changes to the 4.4 to the turbo button and the easy mode. Everything here is pretty similar. AVX offset is -8 because it's 4.8. So essentially what ASRock is doing with their pre-settings is they're saying AVX shouldn't have any overclock at all. I found mine ran at 4.5 just fine, but yours may not. This is high. It works. 1.39 volts is a ton of voltage, and in my particular case was not necessary. Again, they're putting in settings that they consider to be functional for most people. 120 millimeter liquid cooler is a little bit thin for that much overclock, however. I'd want a 240 if I was going to do 1.39 volts. 1.35 was better. Now, setting it to the 4.6 gigahertz auto overclock, you can see down here AVX ratio offset was 6, because 46 minus 6 is 40. And you'll see here it goes to the 1.35 volts that I picked for my 4.8 gigahertz overclock. 4.8 may or may not work for you at 1.35. It may take 1.39. It may not work at all. It may work at less. You might get 5 gigahertz out of your chip. You have to be willing to either play around with these settings, take the defaults, or don't overclock. But these are 3 different ways to overclock in the BIOS. I am generally not a fan of built-in overclocking or auto overclocking or presets because they tend to sort of use the brute force method, extra voltage and very conservative settings, all things considered, to try to give you something that will work for most people. After all, ASRock doesn't want to get boards returned from people saying, I set the overclocking in the BIOS and it didn't work, your board must be faulty. Well, they were perhaps aggressive on their settings, so they're not. But you pay for it in terms of temp and power consumption and possibly shorter chip life, as you saw there at 1.39 volts, one notch below 1.4 on the 4.8 gigahertz preset. But again, every board is going to be different. If you get an ASUS board or an MSI board, they will have similar settings, but there'll be different speeds, different voltages, different presets. Each company does it differently. I'm more a fan of doing it yourself and finding a safe voltage and then just getting the best clock speed out of it that you can. Your system, do it any way you like. Push it harder, get more performance, a little bit more risk, more temp, perhaps shorter system life. The next side-by-side comparison that I'm going to show you is AIDA64 stress testing. AIDA64 goes beyond what just running a game would do. It actually uses all the cores. This particular test does not have the FPU and AVX instructions engaged. The typical use for this sort of system isn't going to use those. An i7 or a Ryzen 7 or a Threadripper or Skylake X would be more likely to use AVX. If you actually need AVX instructions, you need a lot more CPU than this. So I turn them off to show you a typical use case, and it correlates with the game performance. In short, side by side, 4 GHz to 4.8 GHz temp and power consumption. Here you can see the AIDA64 stress test CPU only between 4 GHz stock clock on the left and 4.8 GHz overclocked on the right. Now this is a normal configuration you'd expect for gaming and general online use. The FPU is turned off simply because that's generally not stressed all that much, which is why the game benchmark video shows the games at 4.8, not 4.5. Because you don't really use it that much, so the Avx offset doesn't come into play that much. The temperatures here also coincide with what you'll see in the game performance videos much more. Take a look at the temperatures. We're running around 50 degrees Celsius at 4 gigahertz versus 70 degrees Celsius at 4.8. This is a fairly large temperature increase. Same cooler, same everything. The difference is the voltage, clock speed, power consumption, etc. Speaking of power consumption, come all the way down to the power section. We're using about 40 watts on the CPU at 4 gigahertz and 57 watts at 4.8. This is nearly, not quite, but nearly a 50% power consumption increase for an 800 megahertz clock speed increase. Intel sells this at 4 gigahertz for a reason. That's the efficiency curve. That's where it's happy at best temps, best power delivery. It's the most efficient, and frankly, some of you may choose to run it there. But if you do want to overclock, just be aware it does pull more power and makes a lot more heat. 50% increase in power consumption, or close to it, might sound bad for just a 20% increase in performance, but let's look at that in real numbers. It's less than 20 watts of power. It's 2 or 3 LED light bulbs. It's a third of an incandescent light bulb for a 20% performance increase. Depending upon what you're doing, you may very well appreciate it. And if you're only doing it for maybe 2-3 hours a day, it really isn't that much, all things considered. So it sounds worse than it is. The temps are real. It is a real solid, honest-to-goodness temp difference, and there is a fan noise difference, which I don't really have the equipment to measure, but it is louder when it's overclocked than when it is stock. So if silence is what you want, then either overclocking's not for you or this cooler's not for you. A Noctua or a Be Quiet cooler would be quieter than this. Although not less expensive, the good ones of those are in the $50 to $60 price range with comparable cooling, but they will be more silent. That being said, if content creation and non-gaming performance is important to you, you've come to the wrong video. This is the wrong CPU. This is for gaming. This is for the games I'm going to show you in part 4 of this video series. I am, however, having said that, going to show you a couple of benchmarks comparing it to some other CPUs, including some 6-core 12-thread chips, and show you how well it compares. But the truth is, if you're building this, it should be for gaming. So watch out for part 4 for that. And with no further ado, let's take a look at the benchmarks on this chip. Cinebench R15, the ultimate multi-threaded test. 3D rendering really shows the effect of all the cores and threads a CPU has. At stock speed, a score of 666, and at 4.8 gigahertz, we had a score of 790. This is an 18.6% increase on a just under 20% clock speed increase. So it scales in terms of clock speed very, very closely. Of course, it's nearly a 50% power increase, but it does scale with clock speed. Next up, we have CPU-Z, a very popular free tool you can download yourself. Same results here, a nearly 20% clock speed difference produces a roughly 20% performance difference. Single-threaded versus multi-threaded, stock versus overclock, you get what you pay for essentially. 20% more clock speed gives you 20% more CPU performance, but again, at a much higher power consumption. This next chart compares the performance of several generations older i7 chips, and I specifically picked them because they're sort of the peak or top of the line from the previous generation. Notice that at stock speed, an i3-8350K beats an i7-2600K in both single-threaded and multi-threaded, at least when it comes to CPU performance. Yes, the i7 is a 4-core, 8-thread processor. The i3 is a 4-core, 4-thread chip, but there has been so much change in 6 generations of processors that it doesn't make a difference. The i3 still beats it. When it comes to single-core performance, the i3 even beats an i7 4790K, which has a single-core turbo to 4.4 GHz, and yet the i3 still beats it. 4 generations of improvements, architectural improvements, and other things make the difference. But the 4th gen i7 does beat it in multi-threaded. And then, of course, an i7 7700K beats it in both, but not by much in single-core performance. The new systems really are nice. I also included a Ryzen 5 1600, which is a similar price to the i3-8350K. In terms of multi-threaded performance, of course, the Ryzen 5 crushes it. 3100 versus 1841, it's not even close. If you're doing 3D animation, Cinebench, video editing, the Ryzen 5 1600 obliterates it. Look at the single-core performance. 364 versus 481. The i3 crushes it in single-core, which is why if you're playing games that don't use more than 4 threads, the i3 is a much faster processor. Showing you the same chart, but showing you the overclocked results of the i3. Now, please note that the rest of them have not changed. They're still the stock, and I understand that, but I don't have recent overclocking results of each of those on the current version of CPU-Z. But I do want to show you how much of a difference that overclocking makes if performance matters to you. Notice that we have roughly the same multi-threaded performance between an i7 4790K, again, it's stock to be sure, versus an overclocked i3-8350K. That's pretty cool. Single core performance, it's the fastest chip we have here, and it just goes to show what 4.8 gigahertz really does for you if per core performance is what really matters. Those benchmark results tell a couple of interesting stories. In short, if you don't need more than 4 cores and 4 threads, if you have a workload or play the kind of games that'll be in part 4 of this series, more on that in a second, then this is actually the best performance for the dollar if you're looking for as close to 5 gigahertz as you can get while spending the least amount of money as is reasonable. Now you can change coolers, cases, etc., but the chip and some type of motherboard like this in the $100 to $150 range is the best per gigahertz per core performance you can buy. Now the average person probably is better off with either an i5 or an i7 or a Ryzen 5 or a Ryzen 7. I don't think Ryzen 3s and i3s are the best value for most people. But for people within a specific demographic, it makes a lot of sense. Now, just to be absolutely clear, if you want to play CSGO, Rainbow Six Siege, Overwatch, League of Legends, World of Tanks, World of Warships, Dota 2, if that's what you want to play, then you want to watch part 4 of this video series, because none of those games need an 8-core 16-thread chip, and all of those games will be slower on a Ryzen 7 2700 than they will on this. They really will be. So this wins because of clock speed and instructions per clock cycle. It may not be the best all-around CPU, but it's the best CPU you can get for 4.8 gigahertz on 4 cores, 4 threads at $170, at least in the fall of 2018 when I'm recording this. I mentioned part 4 of this video. I've got 5 different games tested, live gameplay plus benchmarks. That'll be available early on Floatplane. Link to Floatplane down in the video description below. It'll publish maybe about a week or so after this onto YouTube, but they'll publish back-to-back over on Floatplane. $3 per month. No YouTube ads, early access videos, higher quality videos, supports tech deals. I appreciate it, especially since ad revenue isn't what it used to be. And you can download the videos to watch offline, and there are exclusive videos on Floatplane as well. So if you're interested in supporting and you haven't looked at Floatplane before, you might consider signing up if you're able to. $3 a month gets you all of my videos on both of my YouTube channels, some exclusive videos, and all those other benefits. I certainly would appreciate it. If you're not able to, I understand. I appreciate you watching this video. Come back in about a week. Make sure you're subscribed to get part 4 with the game benchmarks. Like this video if you like it, share it with your friends if you loved it. Remember to subscribe to my channel for the big huge red button directly below. Questions and comments in the comment section. And as always, check the links in the video description, the link to the full playlist on this computer build video series, links to all these parts on Amazon and Newegg. Those are affiliate links. They do support the channel. Use those while shopping. It's greatly appreciated. You can also find links to Twitter, Twitch, Discord, and several other things further down in the video description. Please check that out. Thank you all so much for watching. I greatly appreciate it. I will see all of you next time.